All right, number 15, we're going to complete the following steps. There's 5 parts here. We're going to sketch the graph of the function on the given interval. We're going to calculate the change in x. We're going to illustrate the midpoint Riemann sum, sketching appropriate rectangles, and then we're going to calculate the midpoint Riemann sum. So here we just have a linear function. This would be easy enough to graph and visualize by hand. We can use technology. I may do both, just depends on how long it takes. But since this starts at 0, it won't take much to sketch this one. So our y-intercept is 3, 1, 2, 3. And then our slope is 1. So we would go up 1, right 1. And then up 1, right 1 at 2, up 1, right 1 at 3, up 1, right 1 at 4. So this is 3, 4, 5, 6, 7. So we'd have a slanted line intersecting the y-axis, and this would go 1, 2, 3 to 4. This is 3. So we would just have a linear function starting at 3, going and ending at 4 to a height of 7. B looks good. We only got 2 options, A or B, and B is going to be the best. Now we're going to do the change in x. So 4 minus 0 divided by 4. You divide by 4 because of how many tick marks you want. 4 minus 0 comes from your domain. So we get 4 divided by 4, which equals 1. So our change in x is just 1, which is really nice. All right, good there. All right, so we're going to list the grid points. So you start at 0, and then we will add 1 until we get to 4. All right, the midpoint. So midpoint Riemann sum will go to the middle between the 2 selected points. So this is 0, this is 1, 2, 3, 4. Midpoint will go to the middle where it hits the line, and then it would go right, because this will be a line. All of these lines where it hits the graph. So we'll go middle, go left and right, and make a rectangle. So a little bit above, a little bit below. Same thing here. We'll go to the midpoint, and then we'll go to the right till it meets that line, and left. So you'll have a little bit below, a little bit above when you do the midpoint for each one of those. B looks good. B is the one that has a little bit above, a little bit below when you start drawing it out with the midpoint. All right, so now we're going to do the midpoint. So we'll do this one with technology. It's a little bit tedious. All right, so I'm going to go to the graph. I'm going to do all those same steps that we've done before. So I'm going to go to y equal. I'm going to input this function. I'm going to put it in parentheses, so I have a restricted graph. X plus 3. Okay. We're going to apply the restriction from 0 to 4. So remember, normally we have 0 less than x less than or equal to 4. We're going to do one piece at a time. So you have to say divided by, and then we're going to do 0 second math 6. 0 is less than or equal to x, and then second math, go to logic, get the and, because we have two conditions, and then we're going to do x second math is less than 4. Graph it. Okay, should see that piece, right? Go back to the home screen. Now we're going to do the sum. So we're going to do math 0 gives you the summation. Variable x is the input, even though we have k, equals 1 up to 4. And you always do k equals 1 up to 4, or up to your endpoint. And then we're going to recall that function. So I'm going to go vars, y vars 1, and then I'm going to pick y1 because that's where I put my equation. And now we have to input the x value. So y of a is 0 plus, we'll put x for our k value minus 1/2. Changing x is just 1. So you can put the 1, you don't have to, but I will just to kind of keep things so that we understand that we need all those pieces. So we're going to do 0 plus, and then in parentheses, I'm going to do x minus 1/2, and then times 1. So this is the height again, and then at the end, the times 1 doesn't really change anything, but I'm just putting it so you guys can remember. If there was a different value, 2, 1/2, you would have to put those there. So I'm putting them there just so we get used to seeing it. So we have our height times the width. The width is 1, and then this will give us our midpoint Riemann sum, and we get 20.